We're going to start with variables, expressions, and statements. Each module that we move into will always start the same way. There'll be a worksheet with a presentation that goes with it, and then an assignment that follows rapidly after. My keyboard is not working today. And my computer is frozen. This is good. Try again. Wow, we went way down. All right. Variables. Variables are how programs keep track of data. You can think of a variable as a storage unit. And you store things in there temporarily for use later. All variables have 4 properties. You will need to know these 4 properties for the test. The 4 properties are a name or identifier. We call it Fido or Butch or Jenny or whatever. We give that storage space, that storage unit, a name so we can refer to it later. We can say, hey, yeah, that thing I put in storage unit A, I want to go use now. We've got to give it a name. It has a type. You can think of the type as the size of the storage unit. If you were storing a banana and you rented a full-on storage unit down by the freeway, that would be really wasteful to put a single banana in a storage unit like that. By the same token, you wouldn't rent a storage unit that's about the size of a shoebox and say, I want to store my boat in that. That just doesn't work. The type tells the Windows, tells the computer, how much space to set aside for what you're going to be storing here. Memory, you all know memory is usually kind of at a premium when you're running your programs and things like that. You don't want to be too wasteful with memory. And so you like to choose the right size of storage unit for what you're going to be storing. You have to tell the variable, you give it a name and you give it a type. And you say, string. That means I'm going to be storing a string of characters in it. It might be a name. It might be an address or something like that. Int is short for integer. Integer is I'm storing a whole number here. A whole number between 0 and 4 billion or something like that. Positive or negative. So there's name, there's type, then there's a value. The storage unit always has something in it. That something might be nothing. We'll talk about what nothing means later. But when you're storing something there, it needs to have a value, a current value that's stored there. And finally, the last of the 4 is called scope. Scope is basically saying, where can I use this variable? Can I use it just local to where I'm at right now, or does it span the globe? We'll talk about scope on another day, more in depth on another day. But you need to know name, type, value, scope, or you could say the word identifier. When you're giving it a name, there's a syntax that the compiler, Visual Studio, enforces. The C# programming language enforces this particular naming syntax. It can only contain letters, numbers, and underscores. Every other possible character that you can type is not valid. It cannot contain the hashtag. It cannot contain an exclamation point. It cannot contain a period, etc., etc., etc. Letters, A through Z, upper or lower case, numbers 0 through 9, and the underscore. That's the first of the rules. The next rule is it cannot start with a number. So if you want to give it a name, you cannot say 0 name or 1 name. You could spell out 1, O-N-E, name, if you wanted to, or player name. But if you wanted to do first player name, it cannot be 1st. It could be FIRST, player name, something like that. And finally, case matters. Uppercase variable names and lowercase variable names or mixed case variable names are all different from each other. So my variable with a capital M and a capital V is different from my variable where M and V are all lowercase. So case matters when you're giving it a name. So this is the rules for syntax enforced by the compiler. When you type it and you try to move forward, it will underscore it in red and say, I don't know what you're talking about here. Okay? Now the other part is convention. We adopt a convention to make it easier for you and easier for me. And it's a rule that you need to follow. The convention helps to avoid confusion. It will be enforced by me. When you turn in your assignments, I'll look at the variable names that you're using, and if they're out of line with this convention, I'll mark off points. The name should be something meaningful. You could name a variable XXYZ3, and everybody go, oh, what does that mean? Or you could call it player name, something like that. Or you could call it total score, something very clear that kind of explains what it's used for. Usually we don't go too hog wild and type something that's 50 characters long. You can if you want to, but it should be a meaningful name, and it's up to you. We use a convention called camel case. Camel case starts with a lowercase letter, then each subsequent word has the first letter capitalized. And just try to avoid crazy abbreviations. You can use abbreviations, but try not to go too crazy with those. Oh, that's me enforcing it. All right. Type. We talked about type. When you want to store a number, whole numbers are stored using the type int. If you want to store letters, like your name or a place or something like that, you can store null. Null is a key word. Null means there's nothing here. Null can be used with string. Null cannot be used with int. So you would say null, saying I'm storing nothing here. Or I could do quote, quote, which means I'm essentially storing nothing here, but I'm storing a string that has 0 characters in it, which is ironically different than null. Or you could put quotes around any string of characters, quote. And so you could store a name or a title or whatever you want to store there in strings. There are a lot of other types in the C# programming language. We're starting with these first two. We'll expand our world a little bit more and a little bit more as we go through the semester. Expressions are a way where we can take items and combine them together through complex expressions. Think algebra in your head for a moment. Sorry. I hope that doesn't hurt. But expressions always evaluate to a final single value. That's really important to remember. The expressions always have a type. Well, in our world, there are two types right now, int and string. So whenever I ask you, what's the type of this expression, you have one of three answers to choose from. It's an int, it's a string, or it's not valid. It doesn't make sense. It doesn't compute. And we can use operators to combine expressions in complex, crazy ways. For instance, we have the addition operator. You recognize this as the plus sign. If we said 10 plus 3, what would you expect the type to be, or the final answer to be? 13. It would be 13, and it would be an integer, right? Because we're doing integer arithmetic here. We're taking two integer numbers, a 10 and a 3, adding them together, and it's 13. This one should not surprise anybody. This would be 7. 10 minus 3. 10 times 3. Our multiplication operator is the asterisk. So 10 times 3 is 30. 10 divided by 3. Anybody want to hazard a guess other than Peter? He knows the answer to this one.
3.33.
Okay, so we have an integer number, 10, divided by an integer number. What's its output type going to be? Is it going to be an int or a string? It's going to be an int. So what can be stored in the int storage space? Whole numbers only. So thank you, Easton. You walked into that buzzsaw for me perfectly. So 10 divided by 3 in integer arithmetic is 3. No decimal. Just whack it off. Don't round it or anything. Just whack it off. Okay? So 10 divided by 3 in integer arithmetic. So if I said 7 divided by 2, it's 3. Right? 7 divided by 2. 2 can go into 7 3 times. And then there's something left over we just throw away. So 9 divided by 10? 0. 0. 10 can't go into 9 at all. It's 0. It's 0 point something, something, something. Forget the something, something, something. Okay, a new operator that you probably have not had experience with. It's the percent sign, known as the modulus operator. You might remember it as the remainder operator. It takes two numbers and does long division, but gives you the remainder. So if I do 10 divided by 3, 3 will go into 10 3 times with the remainder of 1. Whole number 1. So the answer here would be 1, the integer 1. So what if it's 10 mod? This is sometimes referred to as the mod operator, mod, modulus, remainder. 10 mod 3, 10 mod 5. What is 0? Because 5 goes in there evenly twice with the remainder of 0. So 1 mod 1 is 0. 100 mod 1 is 0, because 1 can evenly go in there 100 times. Does that make sense? We'll be using all of these operators. You'll be needing to understand them just a little bit. Any questions about any of these operators so far? Strings also have operators. String has this plus sign operator. Wait a minute. We already saw this plus sign operator on the previous slide using integers. Now you can use it with a string. When there's a string, see, whenever you see quotes around something, this is an expression that is a string cut. This is an expression that's a string, the letter E. Whenever there's a string involved on either side of the plus operator, the plus changes its mind and says, I'm not doing math, I'm now doing concatenation. So cut plus E becomes cute, C-U-T-E. It just puts them together. Make sense? Now twist your brain a little bit. It'd be 10 and 3. It'd just be 103. The string 103. Is that twisting a little bit? I'm going to keep twisting a little bit more. Get out the vice grips. So, what did I say up here? Anytime the plus operator is involved with a string, it just says it's doing concatenation. So down here, it made 103. Here it says, well, there's a string and an integer. So what's this operator? It's the concatenation operator because a string is involved. So the compiler automatically says, I know you said this is an integer. The compiler is going to treat it as a string. So this is 103 as well, just as this was 103. Okay? Something very similar to this will be on a test. And points will be at risk. So this is the same thing, only in reverse that we just did. A string is involved. This becomes a concatenation operator. Therefore, it's 103 again. Making sense? A little bit? Okay, how about this one? There's no quotes around anything. So this is an integer, a plus sign and an integer. So it's not concatenation. It's just doing 13. It's math now. It's back to math because there's no string involved on either side. This is a trick question. This is a trick question. Both of these are going to be trick questions on the test. Any questions on this? Yeah, anything in quotes means this is a string. Pretty much ignore what's inside the quotes. Meaning don't try to apply some other understanding to what's inside the quotes. Just treat it as a string. Bring it along. Okay, everybody knows about operator precedence, the PEMDAS principle, order of operations. When we have all these different operators involved in an expression, who goes first, who goes second? Do we just do it left to right? Parentheses, exponents, multiplication, division, addition, subtraction. So in this case, we're going to do multiplication and division first. So we'll do 6 divided by 3 is 2. 4 plus 2, 6 minus 1 is 5. Something very similar to this will be on the test. The numbers will be changed to protect the innocent, but the operators will be all in there. And you're going to be going, okay, well, let's see. 4 plus 3 is 7 times 2 is 14 divided by 3 is 14 is 4 minus 1. No, it's 3. You'll get it wrong. Follow the right order of operations. Do multiplication, division first. Do parentheses first. Multiplication, division, exponents, addition, subtraction last. So we already went over that. First priority is those. So the only kind of modification to what you're used to is treat this guy as though he's a division operator, the mod operator. In order of precedence, just treat it like it's a division. And when they're the same priority, just do it left to right. Okay? You'll need this for the test. Okay. Statements. A statement is a complete line or instruction for the computer program. Statements in C# always end with a semicolon. That's going to drive you nuts to begin with. But just remember to end things with a semicolon. And we use braces. Braces are these curly brackets. We use braces to encapsulate or group together a set of statements that we want to treat a special way. That will become more evident in a week or so. All statements are always executed in order that they appear, top to bottom. So a statement. This is a statement. Here's your first C# code. Well, no, you already did some C# code with Drawhouse. This is saying I'm creating an integer variable named I. I'm actually doing a couple things here. I'm doing two things with this one line. Okay, so I'm saying there's an integer. I'm creating an integer variable named I, and I'm getting its initial value of 29. This one is saying I'm creating a string variable called str, and I'm not giving it any value to start with. Strings by default, when you create them, have a default value of null. Integers by default have a value of 0. See the plus signs here? Because strings are involved, those plus signs are concatenation. So this one is saying the string variable, this is an operator. The equal sign is an operator. It's the only one in its class. It's called an assignment operator. It takes whatever on the right side and assigns it to the variable on the left. The left side of an equal sign is always a variable name. We used it here. We're using it here. Here we're saying, so kind of ignore this, because this is basically saying take whatever the final value is over here, and we're going to store it in str. So we're going to start here, and we're going to first do this part. The string Mr. Brooks is, and we're going to add I. I has a value of 29, so we're saying we'll just concatenate 29 to the end of that, so that it says Mr. Brooks is 29, and then we're going to concatenate years old to the end of that. So the final value of the expression is a string that says Mr. Brooks is 29 years old, I wish. And then we take that final value and we assign it into string, or str. How about this one? Well, we know I is 29, so in your brain, just think of I. There's a 29 right here. So 32 plus 29 is 50, 61. Divided by 2 is 30. Is that correct?
No.
Because of PEMDAS, we do this one first. So we take 29 divided by 2.
46.
29 divided by 2 is not 46.
No.
You're jumping ahead. 29 divided by 2, 14, plus 32 is 46. So this is creating an integer variable called value, and we're giving it the value of this expression, which is 46. Now, in our first assignment, the calculator assignment, which you'll be getting here shortly, yes, here's some important things to know or understand. Here, when you want to display text in a text block, whatever the name of your text block is, in this case the variable is named text block, the dot text here is considered a property on the text block. You are not expected to understand deeply what properties are at this point. But it basically says, take the value of this expression. In this case, the expression is a string expression that just says some text, and it's going to assign it into the text property of the text block. In the case of a text block, that means just display this text. So when you want your text block to display some text, you just do this kind of a statement. Notice it's a statement. It ends with a semicolon. Now, if I want to read text from a text box into a string variable, whatever the name of my text box is, .text, that's saying get me this text that's whatever's typed in the text box, and we're going to assign it into a string variable called value. And finally, this one's really important. Value here is a string, but we want to use it as an integer. So we want to take what someone typed and convert it into an integer. We have to run it through this function called convert_to_int32. And so you can put a string value here, in this case it's named value, and it's going to run it through some code to take that string and convert it to an integer, a whole number integer, and we're going to store the resulting value into an integer variable called num. These 3 lines are going to be really important to you. You can pull up these slides on the class website if you want to when we get to that point, or you can write them down. Okay, let's go through the assignment as I lose my voice. Let's go through the worksheet just a little bit together. Okay. So the first one says we're going to write C# code to do the following. We're going to create an integer variable named myScore. Anybody want to hazard a guess how to do that? So int, because we're creating an integer variable, so we say int, and we give it a name. Well, we already were told what the name should be, myScore, and then a semicolon. That's a full-on statement that creates the storage location called myScore that will store integers. Create a string variable named playerName. Same thing, only different. This time we're saying string. We're saying playerName. Straightforward? Assume that we have a variable named answer. We're going to assign 42 to it. Remember how we do the assignment operator? The assignment operator is the equal sign. We take the value over here. We're going to put it into here. So that's taking 42 on the right and assigning it to answer. So answer equals 42 with a semicolon. Now part D here allows you to get creative. We're going to create a variable that will keep track of how many cards have been played. First off, what type of variable would that be? A string to store a count? Probably an integer. So we're going to start the line with int. What should be the name of the variable? Dallin suggests cards played. There's no one right answer here. Okay? What's another that we could call it? Played? What? Card what? Card tracker. What was that? Total cards. So let's go with total cards. How would I spell that? I got total down. What?
Capital C-A-R-D-S.
C-A-R-D-S. And a semicolon. Notice that the first letter of the first word is lowercase and every subsequent word. So if we wanted to say num cards played, or number, we'll go num cards played. Num cards played. We could do something like that. Num is all lowercase. C in cards and P in played are uppercase. Okay, is this making sense? Practically handing this to you. All right. Create a program that first creates these variables. You don't need to write this code. But there's these 3 lines. They've created 3 variables or 3 storage locations. So I have one storage location that's integer is called size, and it currently stores 10. I have another one that's called count, and it currently stores a 7. And I have name, and it stores the string John. That's what these 3 lines did. The first line said, create me an integer variable called size, put a 10 in it, create an integer variable called count, put a 7 in it, create a string variable named name, and put John in it. Hey, I warned you. What's this one going to be? 32. Okay, so because of the PEMDAS thing, I'm going to do the multiplication first. So that's 30 plus 4 is 34 minus 2 is 32. Same numbers, same operators, but now with parentheses. So we can do these first. So this is 14 and 1. 14 times 1 is 14. Size divided by 3. Size is 10. It is 3. Thank you. Integer arithmetic. Hello, the string hello plus the string name. Hello, John. Hello, comma, John. That is a curly comma, but you get the idea. Count mod 2. Count is 7, so I can kind of think of this as a 7. 7 mod 2, so 2 goes in there 3 times with the remainder of 1. Size mod 2. Size is 10 mod 2, 0. 2 goes into 10 evenly 5 times with no remainder. Got it? Good? Good? Part 3. So we have a text box named text box input. Notice how it's named so nicely in camel case form. And we have a text block named text output. I want to display the message, quote, hello, exclamation point, quote, in the text block. Well, the text block is called text output. So I'd say text output dot text is equal to hello, semicolon. Right? We talked about that on a previous slide. This takes the string value and puts it into the text block named text output into the text property. A lot of texts there. Assign the text typed into the text box to a string variable named name. So I need a string variable named name, string name, and it says I'm assigning something there. So it says string variable named name, and the text typed into the text box. The text box is called text box input. Text box input dot text. That's the answer to that one. Is this making sense? Now C is going to throw a little curveball at you because it's saying we're going to convert text from the text box to an integer and assign it to a variable named age. So to start with, I know I need an integer variable named age, and that's equal to something, right? I saw an integer named age. This is kind of a story problem. You're picking things out. So remember, there was on the previous slide, there was the convert to int32. Let me get back to that. No. That one. See where it says convert to int32? And you give it a value here. So we're going to do the same thing. I know this is a little confusing right here. So I better go back. So I'm going to say convert dot to int32, and I need to pass it a string here. I need to give it a string to convert. The text from the text box. The text box is called text box input dot text. Okay, this is a kind of a compound of an expression. So we're taking it innermost here, we're taking the text box input, the text box, we're grabbing the text out of it, we're running it through the conversion code that converts the string to an integer, and then we're assigning it into age, an integer variable named age. I'm going to leave these last two for you to work through. I think you can do that. And while you're working on that, I'm going to hand out the assignment, and then we'll get started. Hopefully you have Visual Studio up and running. And your thumb drive inserted into your computer. Hopefully the dog hasn't eaten your thumb drive yet. Use your neighbors if you get stuck. Or go back to the slides. They'll help you get unstuck too, the presentation. So let's take a look at D and E. Display the message hello XXX in the text block, where XXX is the value of the string variable named name. So we're displaying something in the text block. We called that text output. So we'd say text output dot text is equal to something. So we know no matter what, it's going to say hello. So we're going to put quotes, hello, comma. I'm having a problem with my commas today. And I want the value that's in the string variable called name. So I just say plus name, semicolon. So that takes the string hello, concatenates it to the string variable name, puts them together, creates a new string, assigns it over to textoutput.text. Finally, display the message you are XXX years old in the text block, where XXX is the value of the integer variable named age. We previously created age, so we're displaying it, so it's going to be text output dot text equals. Now I'm going to put quotes, you are, now I don't want XXX there, I want the string, the value of the variable named age, A-G-E, and then I want the rest years old. Okay, that's the last one. May we move on? Anybody need me to not erase this yet? Hold on to your worksheets and leave them with me as you leave the class.
So the fourth part was it name type syntax convention?
No, name type value scope. Scope is the fourth of those. Name has the convention and syntax built into it.
And what's the
Scope
scope again?
we'll talk about on another day. It's how long the variable lives or who can be using the variable.
I'm okay.
You've been logged out.
I still haven't asked. I'll help you.
I've entered in everything that I have. So if it doesn't show up on there, let's talk about what you think. Yes. See, there's an 8 up there and there's an 8 there.
Oh, is my code?
Is that not in there?
No, it's not.
Okay.
I can just plug it into the main.
Yes, that's what you're supposed to do. I will make a note, Colby. To figure out which computer you plug your thumb drive into, look at the number on your monitor and the number on the computer to your left and right and see, make sure that they correlate, because they don't always correlate. All right. We're going to switch to Visual Studio now. And your assignment. I'm starting up Visual Studio. I'm taking my thumb drive and I'm plugging it in. Everybody with me so far? I'll drop this down. This will be a little easier. Yours should look something like this. It might be looking a little bit different. We're going to create a new project. So I'm going to go File, New, Project. We did this when we did Draw a House, but we've got to do it in a very special way. If you go the wrong way, you're going to have to restart. So I say Project. Now, previously, we created a Windows Forms app. We're not doing those anymore. If you selected that, if you run up ahead and already selected that, kill that project, start over. So I could select WPF-app.NET Framework. Make sure it says Visual C# out here. WPF app. WPF stands for Windows Presentation Foundation. Then I come down here and it says, what are you going to name this project? A lot of you overlook this name. I would like you to not overlook this name. This is the calculator assignment. And so I expect something that you can call it my calculator assignment. But the name you use down here, letters, numbers, and underscores only. Don't use any punctuation. It will let you type punctuation, and it kind of confuses Visual Studio a little bit. I still haven't figured out why they allow you to type punctuation. Letters, numbers, underscores only. Don't start with a number. So think of it as like a variable name. It actually ends up becoming a variable name in your code. So that's down here. Now the location, it's going to default to something on your C drive. Now that you have that thumb drive, we never save anything out to your C drive again. I'm going to go off to the right where it says Browse. And I'm browsing my computer. And I plugged mine in. And mine happens to show up as E. Yours is likely the letter D. I'll zoom out so you can see this. And I have a programming class folder that I'm going to put it into. So I've selected, you can put it just right at the root. You could create a folder, programming class, whatever. You could call the folder delete this in May, whatever. But it needs to be the drive letter of your thumb drive. Then the other thing that I make sure is create directory for solution is not checked, and add to source control is not checked. So double check yourself, WPF app, some meaningful name, and somewhere on your thumb drive. And finally, make sure these two checkboxes are not checked. Once you're confident about that part, click OK. It goes through a moment saying creating project. You should get to this point pretty quick. This is your designer window. This is what your program is going to look like. Right now it is a blank canvas of nothingness. And notice there's two tabs up here. One says mainwindow.xaml, sometimes pronounced XAML. This is your designer window. The other one is mainwindow.xaml.cs. CS stands for C#. That's your code window. Typically, you'll have both of those open and you'll switch back and forth. When you're into the designer view, there's this code that appears at the lower portion of your window. This is the raw code that controls the layout of your window. This is XAML code, similar to HTML. Typically, unless you've broken things pretty badly, we don't edit in here. Stay up in here. Stay up on the canvas side of things in the designer window. Anybody having a hard time getting to this point? Okay. I'm going to change the zoom on my window just a little bit so that you can see what I'm doing. So I have this window. I'm going to task switch over to the assignment. The assignment says we want something that looks like, you're going to read through this assignment, but I'm going to walk you through a few of it. The window looks something like this. What do you think these guys are? Text boxes. This is where we're going to be typing text. What are these 5 guys? Buttons. Text block. So I need 3 text boxes. We're going to first create 3 text boxes. Stop doing that. So over here in the upper left, there's a thing called Toolbox. I clicked on my toolbox and it says initializing for a second. And eventually, good grief. I don't know if yours takes that long to initialize. Okay, finally. See that little X up here in the toolbox? Don't ever click that X. Otherwise, you're going to be saying, Mr. Brooks, my toolbox disappeared. How do I get it back? I'll come and show you. So there's 3 categories: common WPF controls, all WPF controls. Click on the little triangle next to common WPF controls if it's not already open. We're going to look for text box. In my window, it's down towards the bottom. And I'm going to click and drag and drop onto my designer window. I placed a text box there. I'm going to kind of put it where I want it-ish. Then I'm going to go back to my toolbox, grab another text box, drag and drop, drag it around. Notice how Visual Studio tries to help you align things so they look visually stimulating. Grab another text box. Yeah, that's a rough approximation. You can always move them around more later if you want, and resize them more later if you want. But you should get 3 text boxes up there. Now the next thing says I need 5 buttons. So I'm going to go to my toolbox. I'm going to grab a button, drag it out there. I'm going to do this one a little bit more quickly. Toolbox, button, drag, drop. Toolbox, button, drag, drop. I'm not worrying too much about layout at the moment. Button, drag, drop. Toolbox, button, drag, drop. All right, I got my 5 buttons out there. I'm going to take the first button and I'm going to start aligning them so they look somewhat useful. Oh, that's a beautiful thing. It's not balanced, but it's there. Now the last thing I need is the text block. So I go to my text toolbox and look for text block, and I drag and drop that puppy out there. Now, I'm going to kind of center him here, and I'm going to, there's these little control dots there. I'm going to make him a little bit bigger. Everybody getting to this point okay? Now the text that appears in each of these controls, these are all controls. The text that appears in each of these controls is a default text. Right now all my buttons are called button. All my text boxes are say text box. My text block says text block. And it's like, okay, that's not too interesting. But now I notice that my window, if I zoom back out on my window, I want to resize my window just a little bit. Things are kind of disproportionately, I have all this extra white space down on the lower half, and I got some extra white space here on the right. I want to resize my window so things fit a little bit more nice and tidy. To do that, there's the window title bar that's up here. I'm going to single click on the window. I'm going to select my window by clicking the very extreme edge there. And you see these little control points off to the right and left and bottom right. I'll zoom in a little bit so you can, well, I'll keep that zoomed how it is. Each of these control points can resize the window itself. You have to first select the whole window, and clues that you've selected the whole window. Down below it shows that you selected the window. Over here in the properties window it says you selected the window. Those are clues that you actually got it selected right. The window. So if I'm not on the window, I go to the extreme upper edge. I'm going to have to fix that on my machine. And I clicked on that title bar thing. And so now I can take those control points and I can kind of drag them in and resize my window so it looks something a little bit more presentable if you're really detail oriented. So I'm going to change my zoom back. Now at this point, all I have done is created an empty shell that has some controls in it. It doesn't have any code behind it at this point. Up in the top center, there's this Start button. Whenever you click Start, I just clicked my Start. It saves the project to wherever you said the project is supposed to be saved to, compiles it, and runs it. This is what my program looks like right now. I can go to the text boxes, and I can type text in the text boxes, and I can click the buttons. Nothing does anything. Then I close the window, and I come back, and I'm back in my designer view. Is everybody to this point? No one is complaining or raising your hand. I'm going to stop here for today. This gives you the first beginnings of your calculator assignment. Close Visual Studio, and then to eject, to eject your thumb drive, down in the lower right corner, there's this one icon that says Safely Remove Hardware and Eject Media. I click on that, and I say eject that guy, and after a second, it is now safe to remove it. That's the safe way of removing your thumb drive. You do that so that you don't lose the files when you're pulling your thumb drive out.